All right, guess it's time for some new ciphers. So moving on from AES, our next talk is going to be by Niels Ferguson. And Niels is going to tell us about observations on H-PRESENT-128, which actually, is that a cipher or what's going on there?
Well, I don't know. So I have to follow that. That's kind of a tall order. H-PRESENT-128 is a hash function proposed a couple of years ago. It's built around a block cipher called H-PRESENT. The block cipher has a 64 bits block size and a 128-bit key going in. All the values you see, all the lines here are 64 bits. H1 and H2 are the chaining states of the compression function. H1 is used there again, and M is the message block. C is some public constant. So last week we had a cryptanalysis workshop at Microsoft Research, and somebody drew this on the board. And I kind of stared at it, and kind of obvious, it's a distinguisher for this compression function. If you take a computation and this left half and the right half are almost identical, the only difference being the XOR with C. So if you take a computation and then redo the computation with H1 replaced by H1 XOR C, then this left half becomes the same as the right half of the first one, with a little correction of XOR C at the end. And you get a trivial distinguisher using two chosen inputs that distinguishes this from a random permutation, random mapping. There's also a distinguisher for the whole hash function. It turns out that H1 prime and H2 prime cannot be equal. H1 and H1, it's the same value going in here, so the feed forward here and the feed forward there are the same. The XOR with C makes the right half different, and so the two halves of the output can never be the same. Take 2 to the 64 outputs of the hash function, and you start to be able to distinguish it. We have a slight improvement on the pseudo-preimage. This is, given an output, can we find inputs that produce this output? The trivial algorithm is, of course, you just try H1, H2, and M values until you hit the right result. The first really trivial improvement is you only compute the left half, and you reject if H1 prime doesn't match, and that gets you twice as fast of the completely generic cipher. But because the left and right halves are related, it turns out that if you do 1/2 computation of the compression function, you can rule out two values for H1. You can rule out this value for H1 using the left half, and you can rule out H1 XOR C using the right half, and that's just because these two halves are so closely related. You end up with a pseudo-preimage that is 4 times faster than the generic exhaustive search. So this is my conclusion. There's a distinguisher on the compression function using 2 chosen inputs, and a distinguisher on the hash functions using 2 to the 64 outputs, and a 4-fold speed up on the pseudo-preimage search. Thank you.